Safety and reliability in manufacturing, especially when it comes to the practices and challenges faced by small and mid-sized factories, is critical. Surprisingly, many factories integral to the aviation and auto sectors still rely on outdated methods, including pen and paper-based quality checks, which can leave room for errors. Today, we'll explore the topics ranging from quality control approaches in smaller factories to lessons learned from notable incidents like the recent Alaska Airlines blowout and the evolving role of technology in shaping the future of safety and reliability in manufacturing processes. To help us uncover perspectives and strategies to enhance safety, reliability, efficiency, and quality in manufacturing for smaller enterprises is Bryan Bauw, Chief Operating Officer of Pico MES. Thank you for joining us, Bryan.
Thank you, Shane, for having me.
So before I dive into my questions, can you first just tell me a little bit about Pico MES and how the company fits into the small to mid-sized manufacturing space?
Yeah, so if I take it back a little bit, the founders spent many years in both large and small factories, seeing how they could run and identifying a few of the opportunities. And after their last experience at one of the startups, they identified the ability to start integrating software with the IoT systems. So the technology has now come far enough that we can start commoditizing and democratizing that kind of bridge that exists between the IT system that is hungry for data and the IoT system that is looking for some context on what's happening. And so it happens at the very top for the large enterprises. They do it. They have very large structured IT, OT teams that take it across. And so what Pico was really designed to do is how do you bring that down to the ability and at a cost point that's accessible to the small and medium manufacturers. So really designed to deploy quickly, connect out to the tools that the worker is doing, and then really augment that operator experience. So I spent nearly 20 years in manufacturing, and I've run many a shop floor on PowerPoint and Excel. Luckily, I didn't have to do the paperwork on most of them, except for the early days. And so what really brought me into Pico is that ability to deploy quickly and accessibly. So it's not a long rollout integration system. And so really you dive more into the how do I run my shop floor philosophy as to how do I adapt to a software philosophy.
What are the common pitfalls associated with traditional pen and paper systems for quality control and safety in manufacturing?
Sheer quantity of data that manufacturers capture is probably the first pitfall. I've read numerous reports that have given different numbers, but manufacturing generates multiple more data than most other industries in the US. And a lot of that is on paper. So you got to think about just going through a mountain of paperwork to try and get back to that. The other thing that the next layer is, are you capturing the right data? And if you are doing that in a pen and paper, or if you're doing that even on Excel, it's hard to know because it's hard to trend that data to get it to, am I actually on path or am I off path? So as you kind of keep layering on these risks with more traditional or legacy methods, you don't identify the opportunities to actually improve those systems using the continuous improvement methods and things like those lines.
So is that where Pico MES comes in, taking the data and doing what it needs to do with that data so that the quality and the safety are, intact?
Yeah, there's a few different things. So we have a few different customers using it at various parts of the journey. One instance, we went into an RV parts manufacturer and provided them with it. What we thought was going to be traceability, but because you provided the digitized tool that goes along with it, you just eliminated the issue carte blanche. So you don't even need the data. All the data does is confirm you're actually operating the way you wanted to. And so we stopped warranty issues there. The reverse is we went into another company and they've effectively replicated one manufacturing line to another location. And the only layer that they changed was the Pico layer. And what you're now doing is providing visibility into what's going on that shop floor. And so they can go in and proactively stop things from occurring, and they've gained 15-ish% efficiency and capability across that just by being able to provide the traceability that comes along with that.
All right, I appreciate that. So what would you say are the key challenges that those small and mid-size factories face in ensuring the safety and reliability in the manufacturing process? What are the biggest challenges for them?
The biggest challenges for small and medium manufacturers, one is time, because they're always under a time crunch to get things delivered. There's a lot of pressure to move things along. They have limited access to resources. You have very sophisticated departments when you get to the OEMs and the larger tier ones that the small and mediums don't have access to. Part of where Pico tries to integrate back into that is creating a tool that deploys extraordinarily fast and integrates into that space. So you're not burdening the SMBs with the access to those digital communication capabilities. So effectively enabling them to access a lot of the error proofing capabilities that the larger companies are still actually after also, to be fair.
Okay. So can you tell me about the digitalization process?
Um, there are lots of approaches to the digitization. Ours is to try and keep it simple. So very much designed from the operator out through to the manufacturing engineer layer out to then the IT system, as opposed to a lot of IT systems. A lot of digitization actually is an IT system that tries to push its way to the shop floor. So keeping it simple, thinking about the operator experience. It doesn't need to be the digitization that some people think of as trying to fully autonomize a shop floor where you're using robots and other um, non-human guided tools. Where we kind of change that ethos is how do you create the pocket around the user, so you're augmenting the human experience and the human capability and really using them for what they're best at, what we're best at, which is the flexibility, the ability to adapt, to change, to realize something isn't as it should be, but creating the systems so that they have a much faster response to if something is out of condition, thus the error proofing that comes along with it. So we do that through kind of a three-phase process. One, you take and digitize the work instructions. A lot of folks, you even go back to the old, I got it on a 3x5 card and someone's come out and redlined it with a red pencil and you're trying to forever keep traceability around that. And there are folks that are still doing that. So once you kind of digitize that, you connect that to the tools they're using. So we have a number of good partners that provide torque tools, digitized printers, scanners, things like that. So again, you're connecting that to the human so they don't have to stop and record or try and figure out what that tool is supposed to be doing. The tool automatically goes to the phase it's supposed to be in conjunction with the work instruction. And then you provide the final layer, which is the traceability, what actually happened, what actually occurred. So if something is out of condition, you have the historical record to then go back and use continuous improvement tools and other methodologies to fix that so it doesn't happen again.